Introduction to TCXO and TSX products. Good day, everyone. Today, we're diving into two essential components used in modern electronics: TCXO's temperature-compensated crystal oscillators and TSX's temperature-sensing crystals. These products are critical for maintaining precise frequency and timing stability in a variety of applications. As systems become more dependent on accurate and stable timing, TCXOs and TSXs have become indispensable. We'll be exploring how they work, their role in modern technology, and why they're so vital in industries like communication, navigation, and industrial automation. The critical role of oscillators in modern technology. Oscillators are fundamental in any electronic system that requires precise timing. They generate periodic signals, which are essential for synchronizing operations within devices. Without oscillators, devices wouldn't have a reliable reference to maintain synchronized functions. From a smartphone's clock to satellite communication systems, oscillators are responsible for ensuring accuracy. TCXOs and TSXs enhance performance by providing precise timing even in harsh environmental conditions. Where temperature fluctuations are common, this makes them essential for mission-critical applications in fields like GPS, communication, and industrial control systems. Product application fields. GPS. Let's start with GPS. Crystal oscillators are at the heart of satellite navigation systems. TCXOs and TSXs are used to ensure precise timing and synchronization of signals. GPS satellites need to stay in sync, so any deviation in timing could lead to location inaccuracies. These oscillators help maintain that synchronization by compensating for temperature-induced frequency shifts. They also improve the system's anti-jamming capabilities. In complex environments, like urban areas or places with heavy electronic interference, these oscillators help keep the GPS signal clean and reliable, which is crucial for accurate navigation. Product application fields. Next up is wireless communication equipment, where TCXOs and TSXs are indispensable. These oscillators are used in mobile communication base stations, cell phones, and wireless devices. They help stabilize signals across various frequencies, ensuring clear and uninterrupted communication. For example, in a mobile communication base station, oscillators support signal modulation, demodulation, and frequency synthesis. As the demand for faster and more reliable mobile networks grows, TCXOs and TSXs help enable high-speed data transmission, ensuring that your calls, internet browsing, and data transfers remain seamless, even in environments with varying temperatures. The origin of TSX. Let's take a step back and look at the evolution of the TSX. In 2009, Qualcomm introduced the XTAL solution to reduce hardware costs in mobile communication systems. This was essentially a single resonator, crystal, combined with an external thermistor. However, the performance didn't quite match the stability offered by traditional TCXO. Over time, engineers improved the design by integrating the thermistor and crystal into a single package, reducing temperature-induced variations. This led to the creation of TSX, or temperature-sensing XTAL. This innovative solution is now widely used in mobile devices, where compact design and temperature compensation are crucial. TCXO and TSX product structure. On this slide, you can see the basic structure of both TCXOs and TSXs. A TCXO integrates a quartz crystal with an IC that includes a temperature sensor and compensation circuitry. This setup allows the TCXO to dynamically adjust its frequency in response to temperature changes. In contrast, a TSX product pairs a quartz crystal with a thermistor, but the temperature compensation happens in the back-end chip, not inside the oscillator. This means that while the TSX provides temperature data, It's the chip that performs the necessary adjustments to maintain frequency stability. Comparison of operating principles. Temperature-compensated crystal oscillator TCXO versus thermistor crystal TSX. Alright, let's dive into the core difference between a TCXO and a TSX from the chip's perspective. It really comes down to where the intelligence for temperature compensation lives. Point to the TCXO column with a TCXO. Our main chip is essentially the boss giving a simple order. The system's frequency budget requires a tight 0.5 ppm stability, and it relies on the TCXO as a complete, self-contained solution to deliver that. The TCXO handles all the compensation internally with its own circuitry. Because of this internal, often analog, compensation method, its temperature curve isn't based on a single, perfect mathematical model. It's a black box that just works. We don't need to model it mathematically on our main chip. Now, gesture to the TSX column now. With a TSX, the relationship is much more collaborative. Here, our main chip is the brains of the operation. It uses a sophisticated, perfect mathematical function, specifically a fifth-order approximation, to model the temperature curve. The TSX itself, which is just a crystal paired with a thermistor, provides the raw temperature data. Our chip then reads this data, applies its perfect mathematical model, and generates a correction voltage to keep the frequency locked. So, the calibration is completed in the chip's software, not inside the crystal component. Summarize the key takeaway. So, in short, TCXO is a standalone, hardware-based solution. TSX is a cooperative, software-driven solution that relies on the processing power of our main chip to achieve that high precision. TSX product sizes. TSX products come in a variety of sizes, tailored to meet the needs of different applications. From compact mobile devices to larger communication systems, there's a size that suits each application. The key here is that despite their small size, TSXs maintain exceptional performance. They are specifically designed to deliver high accuracy and stability without taking up too much space. This small footprint is crucial for modern mobile devices, where space is often at a premium, but performance cannot be compromised. T-curve modeling and key coefficients for crystal oscillators. These 2 pages are for technical teams' reference. TCXO product sizes. Similarly, TCXOs are available in multiple sizes, depending on the application. Whether it's for a portable device like a smartphone or a large-scale communication system, TCXOs come in sizes that can meet the demands of both. The design of TCXOs ensures that no matter the size, the oscillator maintains its stability across a wide temperature range. This precision in design and manufacturing is what makes TCXOs reliable in industries where performance is mission critical, such as aerospace and defense. Temperature compensation fundamentals. At the core of both TCXO and TSX performance is temperature compensation. The quartz crystal, which is the heart of the oscillator, is sensitive to temperature changes. When the temperature fluctuates, the frequency of the crystal also changes. This is where compensation comes into play. Temperature sensors inside the oscillator detect these changes, and the compensation circuitry adjusts the frequency to correct for the shift. By doing this, both TCXOs and TSXs ensure stable performance in a wide range of temperatures, maintaining their precision across various environments. Product manufacturing process. Manufacturing TCXOs and TSXs is a highly precise process. The quartz crystal is cut and shaped with extreme care to ensure it oscillates at the correct frequency. After that, temperature sensors and compensation circuits are integrated into the design. This requires meticulous attention to detail, because even a small misalignment can lead to performance issues. Once the components are integrated, extensive testing and calibration are carried out to ensure that the oscillator meets all required specifications. These tests ensure that the oscillators will perform well under real-world conditions. TCXO test environment. Testing is an essential step in ensuring the reliability of TCXOs. For TCXOs, a variety of tools, such as frequency meters, oscilloscopes, and digital multimeters, are used to test frequency accuracy, phase noise, and stability. For example, we look at how the oscillator performs under different temperature conditions, ensuring it maintains a stable frequency. Phase noise is also measured to assess the purity of the signal, which is important for communication systems where clean signals are critical. These tests are designed to ensure that the TCXO will continue to perform reliably in the field. TSX testing environment. TSX testing requires specialized equipment as well. A network analyzer is used to test the electrical properties of the oscillator, while a crystal temperature chamber simulates the environmental temperature shifts. The TSX may encounter. This testing ensures that the TSX can maintain stable frequency performance across a wide temperature range. By simulating real-world conditions, engineers can verify that the TSX will function properly in devices like mobile phones and communication equipment. The TSX industry landscape customer and competitor mapping. Now let's look at the TSX industry landscape. The primary users of TSXs are manufacturers of mobile phones, tablets, and other communication devices. These oscillators are integral to maintaining the stability and reliability of wireless communication systems. Major players in the TSX market include companies like Epson and KDs from Japan, TXC from Chinese manufacturers. The TSX market is growing rapidly because nearly every communication device needs stable frequency control, making these oscillators essential in the design of reliable mobile and communication technologies. To conclude, TCXOs and TSXs are two of the most crucial components in modern electronics. These oscillators are vital for ensuring the precision and reliability of systems that we rely on every day, such as GPS systems, mobile phones, and communication networks. As we continue to push the boundaries of technology, the demand for these highly accurate and stable components will only increase. Thank you for your attention, and I'd be happy to answer any questions you may have.